All right, let's jump right into this explainer and crack a mystery that trips up almost every Python developer at some point. I mean, why exactly does Python need tuples when lists seem to do the exact same thing? Look, if you've been writing Python for a bit, you're probably super comfortable just throwing your data into square brackets and calling it a day, right? But today, we're going to explore why defaulting to lists might actually be a mistake for certain types of data. What's really fascinating about this question is that it forces us to think about the actual intent behind our code. Now, lists are absolutely fantastic. They're your messy, changing scratch pads. You can append to them, pop things off, randomly change the item at index 0. They're literally built to be dynamic. But what happens when you have data that's sacred, data that absolutely should never be altered once your program starts running? Sometimes your code doesn't need a dynamic scratch pad. Sometimes it requires a permanent, highly secure document. And that is exactly where tuples step in. So here's the deal. A tuple is basically a locked record, and I really want you to hold on to that specific analogy throughout this explainer. Written with parentheses, a tuple is an ordered sequence of items, just like a list, but it has one massive fundamental difference. It's immutable. Meaning, once you create it and close those parentheses, boom, the vault is shut. You absolutely cannot add, remove, or change any single element inside it. Think about it. If your data represents the days of the week or the core configuration settings of your entire app, you really don't want a rogue line of code accidentally changing Monday to Funday. A tuple physically prevents that from ever happening. Let's break down the head-to-head differences here. Syntax-wise, we're trading the square brackets of a list for the parentheses of a tuple. We already talked about mutability. Lists say, yes, change whatever, while tuples give you a hard no. But because tuples are entirely locked down, they actually use slightly less memory and give you faster performance. Python can optimize them under the hood in ways it literally just can't do with a constantly shifting list. And crucially, and we'll unpack why this is a total superpower in just a second, tuples are hashable. That means they can be used as dictionary keys, whereas lists definitely cannot. Okay, so let's see how this translates into your everyday coding, because there is a major syntax trap here that catches a massive amount of developers. Creating a tuple with 3 items? Super easy. Creating an empty tuple? Also easy. But if you want to create a tuple with just one single item, you absolutely must include a trailing comma. This is literally non-negotiable, and honestly, it's one of the most common, frustrating bugs you will ever hunt down in Python.
Forgetting that little comma is a really dangerous anti-pattern. If you just put a single word inside parentheses, Python assumes you're just grouping a regular string, the exact same way you'd use parentheses in a math equation. It completely ignores them. But adding that simple trailing comma correctly signals your intent to the interpreter. That one tiny character basically screams, hey, lock down this data, this is a tuple.
To prove the gotcha, take the word ginger, for example. If we wrap it in parentheses and add our vital trailing comma, Python correctly identifies its class as a tuple. But, and here's the kicker, if you just put ginger in parentheses without the comma, Python just sees a standard string. Actually, scratch that. It sees a string wrapped in completely useless parentheses. So, write this down. Always, always remember the comma for a single element tuple. All right, earlier I teased a superpower, and it is time we unlock it. Because a tuple is a locked record, it possesses a trait called hashability. Now, I know hashable sounds like some heavy computer science jargon, but it simply means Python can rely on this object to never, ever change its identity during its lifetime. Because it's immutable, its hash value remains completely constant. And in Python, if you want an object to act as a key in a dictionary, it has to be hashable. It has to be trustworthy. So why does this matter in the real world? Well, think about mapping complex data like GPS coordinates. You can actually format your coordinates as tuples and use them as the secure, unchangeable keys for locations like Mumbai or Delhi. You can reliably look up a city using its tuple coordinate because Python knows that tuple isn't going anywhere. But try doing that exact same thing with a list, and Python will immediately throw a massive type error. Since a list could theoretically change its coordinates mid-program, Python straight up refuses to let you use it as a dictionary key. Tuples make this kind of advanced data mapping possible. Okay, get ready for a bit of a mind blower if you've been using Python for a while without realizing this. Whenever you write a function that returns multiple values separated by commas, say a function returning both the minimum and maximum of a dataset, Python is actually implicitly packing those values into a locked tuple behind your back. You probably didn't even type the parentheses, but the comma itself creates the tuple. So, you've likely been relying on tuples this whole time to safely transport data out of your functions without even knowing it. Let's do a quick rapid-fire recap to really cement these core concepts before we wrap up. First, flashcard. What happens if you try to modify an element inside our locked vault? Let's say you try to reassign index 0. What does Python do? It slams on the brakes. You'll immediately get a type error stating that the tuple object does not support item assignment. The lock is completely unbreakable. Second flashcard. Do tuples support slicing? So we know we can't write to them, but can we read them dynamically? Oh, absolutely. Even though they're locked down incredibly tight against modification, you can still easily read from them using the exact same start-stop-step slicing syntax that you already know and love from lists and strings. Immutability only restricts changing the data. Reading it is totally fair game.
And the final flashcard, why are tuples slightly faster than lists? We touched on this, but it's absolutely crucial. Because tuples are locked records, Python doesn't have to over-allocate memory just in case you decide to add more items later, which is exactly what it has to do with lists. Python can easily optimize immutable sequences, which means less memory overhead and faster execution for your apps. It's a literal performance boost just for choosing the correct data structure.
So we've seen how tuples act as secure, immutable sequence vaults. We've tackled the single-element comma trap, unlocked the superpower of hashability for dictionary keys, and seen the performance benefits of locking down your data. I want to leave you with this thought today. I challenge you to review your own projects. Where are you currently using a flimsy list for data that should actually never, ever change? Find those vulnerable lists, swap them out for secure, locked record tuples, and watch your code become safer, faster, and way more intent-driven. Thanks for joining me on this explainer, and I'll see you next time.